Okay, so why did we use math induction? To prove a formula true for all n, right? What was the first step to math induction? Show that it works for n equals 1. Now, the one I've got on the screen, which looks different than the ones we did, it's clearly, it's showing you that the sum of the nth term of a geometric sequence equals the sum, the formula we're already using for the sum of a geometric sequence. Okay, so we're going to try to prove that's true using math induction. So if I substituted n equals 1, if I put in n equals 1 here and here, I want to show that it's the same on both sides. Well, if I put in a 1 there, what it means is I'm only actually doing this formula once, right? It's going from I equals 1 to 1. So basically, that's going to be A1 times r to the 1 minus 1, which is A1 times r to the 0, which is A1. Okay. Now you come over here, if we have A1 times 1 minus r to the 1 over 1 minus r, that's 1 minus r over 1 minus r is 1. So the whole thing is A1. So it checks for n equals 1. Okay. Then we want to show that if we assume that the formula works for the first k terms, that if I add the next term, the k plus 1 term, it will also work for k plus, adding up k plus 1 terms. So how do I find, this is my an here, this is my sn here. How do I find s? Let me erase the little ones that I did there. If this is Sn, how do I find Sk? Plug in k into n, right? So that will be A1 times 1 minus r to the k over 1 minus r. That's the Sk. How do I find that ak plus 1 if this is an? Put the k plus 1 in here, right? So what am I going to get if I put in r to the k plus 1 minus 1? It's r to the k, so it's a1 times r to the k. And then how do I get the sk plus 1? This is the Sn. How do you find sk plus 1? Plug in for n, k plus 1. It only shows up in one place, right? It's right there. A1 times 1 minus r to the k plus 1 over 1 minus r. So again, by using the formula already, we've assumed that it works for n equals k. We want to show that it works for n equals k plus 1 by showing that the left-hand side equals the right-hand side. We don't know that that's true. That's why I put a question mark over it. So remember, we either work on the left, make it look like the right, work on the right, make it look like the left, or make them meet in the middle somewhere. And do you see any common factors in every term? Nope. A1. There's an A1 here, here, and here. So I'll cancel those. Divide them out. Right? Divide every term by A1. Divide both sides by A1. That's algebra, right? Do the same thing to both sides. That means divide each term. You have 2 terms here. You got 1 term here. Divide them all by A1. Gone. What did we normally do when we had denominators involved? We multiplied by that denominator, right? So in this case, the denominator in 2 of the terms is 1 minus r. So let me multiply this by 1 minus r times 1 minus r. And again, don't forget this one right here, 1 minus r. Blue. Right, so in this first term, 1 minus r's cancel, and I've got 1 minus r to the k. In the next term, I've got 1 minus r times r to the k. On the right-hand side, 1 minus r cancels, and I've got 1 minus r to the k plus 1. Okay. Let me use distributive. Yeah, Josh. 1. Distributive property, 1 minus r to the k plus r to the k times 1, r to the k times r. Okay, what simplifying could I do right away? It's not r to the 2k. Yeah, it's negative rk and positive rk. They cancel. Right, cancel, cancel. So all that's left now is 1 minus r times r to the k. And we dealt with this exactly in that number 11 homework problem, right? How do you simplify r times r to the k? Remember we had 2 times 2 to the k? Properties of exponents. What is x squared times x to the third? X to the fifth. You add the exponents. Okay, well, what do you, this is r to the first, and that's r to the k. R to the k plus 1. 1 minus r to the k plus 1. Okay. But that's the same thing that we've got on the right-hand side. So we just showed that the left-hand side equals the right-hand side. So by assuming the formula works for n equals k, we showed that it means it works for k plus 1. That means since it already works for 1, it must work for 2. If it works for 2, it'll work for 3, and so on to infinity, right? That's math induction.